So objective 5 is to find the break-even point given a cost and revenue function. So we're going to look back at section 3.3, and if you want to look at example 7 on page 138, that's where it talks about this. And many problems in business involve analyzing revenue, cost, and profit. So we use capital R, capital C, and capital P to represent these quantities. We use lowercase r, c, and p for other things later. So make sure you're using an uppercase for the revenue, cost, and profit. So the break-even point is the point where revenue equals cost, so there's no profit. The profit is 0. So recall that profit equals revenue minus cost. So it's two different ways of saying the same thing. Either the revenue equals cost or the profit is 0. Both have the same meaning of the break-even point. So as a business, what you hope you get to is the point where the revenue is bigger than the cost and you become profitable. So on page 15 in the book, you can find the formula for the total revenue that says it's the price per item times the number of items sold. Well, quite often that number of items sold is going to be an X variable. But just for an example, if I have $50 per pair of shoes and I sell 6 pairs of shoes, we know our total revenue would be $300, that we need to multiply those two numbers together to get the total revenue. Then cost has two components, fixed costs and variable costs. And the fixed costs are those which you incur whether or not you actually produce anything. So things like your rent and insurance are often fixed costs. And the variable costs are things that would change depending on your production level. So things like salaries for workers and raw materials and shipping and those kind of things. So your total cost might equal your fixed cost of $1,200 plus your variable cost, which is 50x, where x is the number produced or made. We use those words kind of interchangeably in this class. So here's an example of a break-even analysis where we want to find the value of x for which the given products will break even. Well, if you want to know when something happens in math, you write the math sentence that says it is happening and then solve for the value of x that makes it true. So if we want to know when cost equals revenue, or the break-even point, we write the math sentence that says the cost equals the revenue. And then we solve for the x value that makes that true. So to solve for x means to get x by itself. So we're going to subtract 100x from both sides and get 6,000 equals 400x. And then divide both sides by 400. And we're going to get x equals 15. So whatever x is representing, cases of salsa or tetherball poles or whatever it's representing, when you sell 15, you will exactly break even. So what you want to do is figure out how to do better than break even. So now we're going to go to section 2.4 on page 95 for objective 6, which is graphing a linear inequality in two variables. So we started by graphing lines because the first part of graphing a linear inequality is to graph the line you get when you replace the inequality with an equals. So if you have y is greater than or equal to 3x minus 2, that's a linear inequality in two variables. And you start by graphing y equals 3x minus 2. So once that line is graphed, then you need to indicate which half of the plane is a solution set for the inequality. So you either shade above or below the line. So let's talk about how you decide. So the first method I call the pick a point and test it method. You choose a point on one side of the line. If 0, 0 is not on the line, it's a good choice because it makes the arithmetic easy. If 0, 0 is on the line, you'll have to pick a different point. Replace the x in the inequality with the x coordinate of your point and replace the y with the y coordinate. And then the next step is a logic exercise. If the point you chose makes the inequality true, every point on that side of the line will make the inequality true, and the solution set, you shade the side where your point is. If your point that you picked makes the inequality false, then the solution set is on the other side of the line from your point. So you shade away from your point. And I need to see your work for this. Okay, so to graph the inequality y is greater than or equal to x plus 2, we first graph the line y equals x plus 2. So we graph the y-intercept of 2, slope of 1, draw our line. Okay, then we're going to choose the point 0, 0. So what I would want to see is something like test 0, 0, and then do that. So tell me what you're going to do and then do it. That works the best when you're writing your work out for somebody else to read. So the question is 0 greater than or equal to 2? And the answer is false. So you need to shade away from 0, 0. So this direction is away. And if you learned to shade, that's fine. I think you'll find in this class we're doing some pretty complex graphing of multiple inequalities, and so it gets kind of messy. So it's usually easier to see with the little arrows pointing to the solution set rather than actually shading. But you're free to do it either way. So second method is the above-below method. If you use algebra to rearrange your inequality to get y isolated on one side, then you can use reasoning to decide which side to shade. So if you have that the y is bigger than the formula with the x, that means you want y values that are larger than x plus 2. You want values of y that are above the line. So if you have y is larger than, you want to shade above the line. If you have y is less than, you want values of y that are smaller than the ones on the line. And smaller y values are lower on the grid, so you shade below the line. And again, I need to see your reasoning for this, but once you get the y isolated, it can be as simple as writing shade above or shade below. So this method might need some algebra if your inequality looks something like the general form that we've been looking at, and you would need to solve it for y before you could use the above-below method. So we're going to have negative 6x minus 12 then on the right, divide both sides by 4. And get y is greater than or equal to negative 3/2 minus 3. So after you've graphed the line, you would shade above. Okay, and then just a little reminder, working with inequalities is very similar to working with equations with one extremely important difference. When you multiply or divide both sides of an inequality by a negative number, the direction of the inequality reverses. Let's look at why that happens. So let me have a number line here, and we're going to look at the numbers 1 and 2 and compare them. And 1 is smaller than 2, I think we'd all agree, right? Well then, if I multiply both sides by negative 1, now I have the numbers negative 1 and negative 2. So multiplying by a negative number has the effect of moving the points to the other side of the 0 on the number line. Well, when we talk about which number is greater to the left of 0, it's the one closer to 0. So negative 1 is bigger than negative 2 because it's to the right on the number line. So we can see that the effect of multiplying both sides by a negative number was for the two numbers to reverse their relationship to each other. So let's look at this example, and I'll do it both ways. So I would use the intercept method for drawing this line. So I would say when y is 0, x is 2. And when x is 0, y is negative 4. So go ahead and label your x and y axes. And then 2, 0 is on your line, and 0, negative 4. And then I always put additional dots so I can keep the line nice and straight. So there's my line. So now I can test 0, 0. And 0 is definitely less than 4. So we're going to shade towards 0, 0. So 0, 0 is on this side of our line, so that's the solution side. So the other way you could do it is to solve this equation for y by subtracting 2x from both sides. And get negative y is less than or equal to negative 2x plus 4. Then I'm dividing by a negative number. So that means the direction of the inequality will reverse, and I'll have y is greater than or equal to 2x minus 4. So when I have it written this way, I can see that I need to shade above, and so I get the same result. Now just a little note about the 4 different inequality symbols. When the equality is included, the graph of the line is solid to indicate the points on the line are part of the solution set. They make the equation equal. When the equality is not included, that's called a strict inequality, the graph of the line is dashed. We don't run into this a lot, but I just wanted to make sure you remembered that. So more often than not, we're going to have the inequality with the or equals to. So let's see how we would do this example. 4 does not divide evenly into 9, so I can't use the intercept method. So instead, I'm going to solve for the y. I'm dividing by negative 3, so the inequality reverses. I'm going to label my axes. And I start with my y-intercept of negative 3. And then I go up 4 over 3. Up 4 over 3. And draw my line. And then what I actually do is then I look and say, oh, it was a strict inequality. So I erase pieces of the line so it looks dashed. Okay, then because I have already solved for y, I can just look at my inequality with the y by itself on one side and say, that means I need to shade below. Or you could also test 0, 0 and say 4 times 0 minus 3 times 0. Is that bigger than 9? Nope. So shade away from 0, 0. And you see that you'll have the same portion of the graph shaded. Okay, then objective 7 is to graph a system of linear inequalities. So you can see that we're building and building. We graphed lines, then we graphed linear inequalities, just one. Now we're going to graph a system of inequalities. And we're building up to the whole linear programming process, which depends on us finding what's called the feasible region. Okay, so I'm going to want you to be really organized about this, and I usually label the equations so I can make my work really clear of what is it that I'm working on. So I would use the intercept method here again. I would say when y is 0, x is 4, and when x is 0, y is 4. So here's my origin. So I would say I have 4, 0, and 0, 4. So there's my line. And then I'm going to test 0, 0. and I get true. So that means I want to shade toward 0, 0. Okay, so now I'm going to do number 2. And again, the intercept method will work really nicely here. So when y is 0, x is 2. When x is 0, y is negative 2. So 2, 0, and 0, negative 2. Okay, and then I'm going to test 0, 0. And this is false. 0 is not bigger than 2, so I need to shade away from 0, 0. So I want to see the individual shading for each line. And then I want you to look for where is the overlap. So you can see that we've divided the plane up into 4 regions. We'll call them A, B, C, and D. So the region we want is this region D, because that's where both inequalities are true. So this is called the feasible region. This is the only possible operating scenarios that work for your situation once we get to word problems where we're actually talking about real situations. Okay, so we have graph the feasible region for the given system of inequalities. And I'm going to make a separate video for this one because it's fairly complex and I don't want to rush it. So one more video.